Hello everyone and welcome back to my channel. In today's video, we are going to discuss some applications in real life situations about logarithms. So let's get started. So hello everyone, welcome back to my channel. In today's video, we are going to discuss the next lesson under logarithm. So that would be, since we're done with the introduction to logarithms, now this time application in real life situations of logarithms. So we'll be discussing a little bit of applications or some applications of logarithms in the actual life scenario. So we have here the objectives. Represent real-life situations using logarithmic functions and solve problems involving logarithmic functions. So where can we apply logarithms? So we have here some of the most common applications in real life of logarithmic are, we have Richter scale, we have sound intensity, we also have pH level. Now let's start with the problem. So the first application is the Richter scale. Now how is logarithmic or logarithm, the concept of logarithm applied in the Richter scale? So we have here, in 1935, Charles Richter proposed a logarithmic scale to measure the intensity of an earthquake. He defined the magnitude of an earthquake as a function of its amplitude on a standard seismograph. The following formula produces the same results, but is based on the energy released by an earthquake. Now we have here the earthquake magnitude on a Richter scale. The magnitude R of an earthquake given by this formula. So we have here R is equal to 2/3 times log E over 10 raised to the power of 4.40, where E in joules is the energy released by the earthquake, and the quantity 10 raised to the power of 4.40 joules is the energy released by a very small reference earthquake. Okay. Now, so you have here, suppose that an earthquake released approximately 10 raised to the power of 12 joules of energy. Letter A, what is its magnitude on a Richter scale? Letter B, how much more energy does this earthquake release than the reference earthquake? Now let's have the solution. So for the solution, we have here, for letter A, you have E is equal to 10 raised to the power of 12. Okay, that's the energy release. Then we are going to substitute that to our E. So we have here R is equal to 2/3 times log E over 10 raised to the power of 4.40. Now substitute the value of E. We have R is equal to 2/3 times log 10 raised to the power of 12 over 10 raised to the power of 4.40. Next, we have, since we are dividing 10 raised to the power of 12 over 10 raised to the power of 4.40 with the same base. Now, kindly recall the laws of exponents. What are we going to do with the exponents if we are dividing with the same base? So, we are going to subtract. So, that is 10 raised to the power of 12 minus 4.40. That will give us 10 raised to the power of 7.6. Now, therefore, we will have R is equal to 2/3 log 10 raised to the power of 7.6. Then, we can use a scientific calculator to get the value of log 10 raised to the power of 7.6. That is 7.6. Now, times 2/3, that will give us the value of R, which is approximately equal to 5.1. Okay, now For now, guys, you are going to use a scientific calculator to get the value of 10 raised to the power of 7.6. However, in our next lesson, we'll be discussing how to do it manually without using a scientific calculator. Now, for letter B, the question was, how much more energy does this earthquake release than the reference earthquake? Now, the earthquake releases 10 raised to the power of 12 over 10 raised to the power of 4.40. Then we got 10 raised to the power of 7.6, which is approximately equal to 3 million, we have 398,10717. So that's 39,810,717 more energy than the reference earthquake. Okay, so that's it. Let's proceed to the next application, which is sound intensity. Now, in acoustics, the decibel or dB level of sound is, by the way, the decibel is the unit measurement. So we have here D is equal to 10 times log I over 10 raised to the power of negative 12, where I is the sound intensity in watts per square meter. The quantity 10 raised to the power of negative 12 watts per square meter is least audible sound a human can hear. Now, let's have an example. Now, the decibel level of sound in a quiet office is 10 raised to the power of negative 6 watts per square meter. What is the corresponding sound intensity in decibels? Then, how much more intense is a sound than the least audible sound a human can hear? Now, let's proceed to the solution. For letter A, we have the formula D is equal to 10 times log I over 10 raised to the power of negative 12, which is equal to 10 log, the given is 10 raised to the power of negative 6, that's the intensity, over 10 raised to the power of negative 12 is equal to 10 raised to the power 10 log 10 raised to the power of 6, because we are subtracting expressions with the same base. So you have 10 raised to the power of negative 6 over 10 raised to the power of negative 12. We are going to subtract their exponents. So that's negative 6 minus negative 12. That gives us 6. Therefore, we have 10 log 10 raised to the power of 6. And using a scientific calculator to get the value of log 10 raised to the power of 6, we will come up with 6. So that will be 10 times 6. Therefore, we have the answer 60 decibels. So that's the corresponding sound intensity in decibels. Next, how much more intense is the sound than the least audible sound a human can hear? So we have 10 raised to the power of negative 6 over 10 raised to the power of negative 12, subtracting the exponents with the same base. That gives us 10 raised to the power of 6, or 1 billion more intense than the least audible sound a human can hear. Okay, then let us proceed to the next example or next application. So we have here acidity and the pH scale. Now, the pH level of water-based solution is defined as pH is equal to negative log times H, or log H. That's actually in chemistry, that's hydrogen ion. Okay, where H with positive is the concentration of hydrogen ions in moles per liter. Solutions with a pH of 7 are defined neutral, and those with pH less than 7 are acidic, and those with pH greater than 7 are basic. Now, in chemistry, we call this basic as alkaline. Now, let's have an example. So we have here a 1 liter solution contains 0.0001 moles hydrogen ions, and find its pH level. Now, for the solution, we're going to convert this decimal 0.0001 into exponential form. With a base of 10, you have 10 raised to the power of negative 5. Then you have pH is equal to negative times log H, or hydrogen ion, which is 10 raised to the power of negative 5. Now, if you're going to use a scientific calculator to get the value of 10 log 10 raised to the power of negative 5, that will give us negative 5. Then negative 5 times negative, that gives us pH level of 5, which is, since if the pH level is less than 7, since 5 is less than 7, therefore it is acidic. Okay. Now, it's time for us to have a quiz. Now, this time, you're going to answer. So, number 1, you have here, what is the magnitude in the Richter scale of an earthquake that released 10 raised to the power 14 joules of energy? How much more energy does this earthquake release than that of reference earthquake? Number 2, suppose the intensity of sound during takeoff is 100 watts per square meters. What is the corresponding sound intensity in decibels? Then, how much intense is this sound than the least audible sound as human can hear? Okay, so I hope that you're going to apply the concept of logarithm in this particular real-life scenario problems. So before we're going to end our lesson, let's have a math saying. So without mathematics, there's nothing you can do, and everything around you is mathematics. Everything around you is numbers. So thank you so much guys for watching. Don't forget to subscribe my channel. Bye-bye.